Hi, I'm Gert-Jan de Mulder and I worked on the PROV4ITDaTa project. PROV4ITDaTa revolves around the direct and transparent transfer of personal data to personal data stores. Have you ever wanted to move your personal data to somewhere else? Maybe you're just bored with what Facebook has to offer and there's some other service that provides exactly what you need. Just like many other providers, Facebook will only give you the option to download your personal data as an archive, and that's it. The personal data in these archives is structured according to the provider's custom data model in a format of their choice. In the following slides, I will go into greater detail about the current situation and problems regarding the transfer of personal data. Secondly, I will unveil how our solution, PROV4ITDaTa, provides the means to let users transfer heterogeneously structured personal data to a personal data store. It will become clear how we leverage RML.io, Comunica, and Solid to achieve our portability tool. As mentioned earlier, our personal data can be scattered across service providers such as Facebook, Flickr, and Imgur, for example. They are eager to help you store your data on their servers where the data is structured using custom data models. However, moving the data elsewhere is a less trivial matter, which negatively contributes to the vendor lock-in where users become reliant on a single provider. There are existing service-to-service portability platforms that allow users to move their data. However, these solutions are hard-coded and have some drawbacks. We can conclude that there is a need for a configurable portability tool to transparently transfer personal data to personal stores. Alright, it's time to reveal our solution. Our solution, called PROV4ITDaTa, is an open source web application that enables users to transfer their personal data as linked data to personal stores, called solid pods. We allow for a fine-grained configuration so that users have the flexibility to choose how and what to transfer. We achieve this by leveraging open source solutions RML.io, Comunica, and Solid. An overview is illustrated on the diagram and can be divided into three parts, namely the RML.io part at the lower left of the diagram, the Comunica part at the upper right, and the Solid part right in the middle. Each of them will be discussed on the following slides. Starting with our first component, RML.io. RML.io is a set of open source tools to generate RDF knowledge graphs from heterogeneous data sources by means of a declarative set of rules, referred to as RML rules. These RML rules describe how the sources are accessed and how the source data will be transformed. Being a declarative set of rules allows for automatic provenance generation about the resulting RDF dataset. So let's see how we use RML.io in the PROV4ITDaTa use case. We let users choose from a curated list of RML rules that describe on the one hand from which service provider the data will be consumed and on the other hand how the data will be transformed to RDF. Currently, we support Google, Flickr, and Imgur, but this can easily be extended to more. Users are able to choose the vocabularies that will be used for the transformation, such as schema.org or DCAT, for example. So, we give the users the flexibility to decide how their personal data will be transformed. The RML processor will consume the service provider's web API and perform the described transformations. It will generate the RDF data accompanied by provenance statements, which contributes to the transparency of our solution. Now that we have discussed how the intermediate RDF datasets are generated, it's time to discuss how to select the specific parts to make the final dataset. Let me introduce to you the second component, Comunica. Comunica provides a meta query engine which is designed in a highly modular and configurable manner to deal with the heterogeneous nature of linked data on the web. We have configured a custom Comunica engine that allows us to query protected files on the solid pod. That enables us to select specific parts from the intermediate dataset, having a bluish color on the diagram, and eventually create a final dataset, which is colored in black. To give an example, we could have intermediate datasets for Imgur photos, Flickr photos, and Google Contacts. We could now create a final dataset that only contains photos that can be linked to my contacts, hence allowing for a fine-grained configuration of the transfer. We are also developing a provenance feature, which will be discussed later on. Alright, so far we've been mostly talking about generating and querying data, but where will we store it? The Solid ecosystem encapsulates a set of W3C standards and tools based on the linked data principle. Solid includes decentralized personal data stores, called solid pods, and by storing R-generated datasets on those solid pods, users are in complete control of their personal data. Alright, now that you have an idea of what our solution is, it's time for a demo. This demo shows the process of transferring Google Contacts and Flickr photo sets to a solid pod. First, the user can select from a curated list of RML rules and inspect them. Upon executing the chosen RML rules, the user will be guided through the authorization process for the corresponding service provider. When the authorization was successful, the RML processor will start executing the RML rules and generate RDF and provenance data. Next, the generated RDF and provenance data are stored on the solid pod and made available to the user for either inspection or download. The same workflow is now being repeated for consuming photo sets from the Flickr web API. As you can see, the user only sees a difference in the authorization procedure. As mentioned before, we are also working on integrating provenance in Comunica. The following demo will show source-level provenance. The demo shows running a query over the intermediate datasets that not only show the result of the query, but also the metadata with source-level provenance, containing the number of items of the result as well as the number of items that originate from each queried source, in this case, the intermediate datasets. Okay, so let's summarize all of this. PROV4ITDaTa is completely built upon open source tools that lets users transfer personal data to personal data stores. PROV4ITDaTa also allows for a fine-grained configuration of the transfer. Furthermore, the configurability increases the reusability of existing RML rules. We obtain a transparent solution. Prior to executing the transfer, users can inspect the RML rules and queries. Afterwards, the applied transformation and originating sources of the resulting data is provided in the provenance data. Last but not least, since the transformations as well as the generated results are all in RDF, we are able to obtain a high level of interoperability. You can experiment with PROV4ITDaTa yourself. You can use your own RML rules to transform your personal data to RDF and write your own Sparkle queries to create a refined and final dataset. Moreover, you will be able to see the transformations that were involved during the transfer using the generated provenance data. The links to the online demo and the source code are shown on the slides. Should you have more questions, don't hesitate to reach out.